I do think that we live in a shared world. And if everyone has their own customized model, which really is a little virtual world that they live in, that's basically how you get polarization. And I think that is a problem that we want to fight. If you think about each of these language models in the future, I think a primary way that we'll interact with the world and get information and also take action in the world is probably going to be mediated by these models. So that better be tethered to reality and not just based
Mhm.
on some money making ad scheme that gets people to basically believe whatever they want.
Mhm.
And there needs to be some sort of shared reality, if nothing else, because the real world demands it.
Hey there, I'm your host, Kan Jun, and we are an independent research lab developing AI agents that mirror the fundamentals of human-like intelligence and that can learn to safely solve problems in the real world. On our podcast, we interview researchers about their behind-the-scenes ideas, opinions, and intuitions that are hard to share in papers and talks. We hope you learn as much as we have in our quest to understand and build the mind. Percy Liang is an associate professor of computer science and statistics at Stanford. These days, he's interested in understanding how foundation models work, how to make them more efficient, modular, and robust, and how they shift the way people interact with AI. Although he's been working on language models for long before foundation models appeared. Percy is also a big proponent of reproducible research, and toward that end, he shipped most of his research papers as executable papers using the CodaLab Worksheets platform that his lab developed. And he's also published a wide variety of benchmarks. Percy Liang is an associate professor of computer science and statistics at Stanford. These days, he's interested in understanding how foundation models work, how to make them more efficient, modular, and robust, and how they shift the way people interact with AI. Although he's been working on language models for long before foundation models appeared. Percy is also a big proponent of reproducible research, and toward that end, he shipped most of his research papers as executable papers using the CodaLab Worksheets platform that his lab developed. And he's also published a wide variety of benchmarks. Thank you so much for being on the podcast. We're really excited to have you. You've had a long career. Well, actually, you've had a short career that has
It's all
very
relative.
dense. It's all relative.
Mid-career. I think that's the proper name for it, mid-career.
Mid-career, but it's been very, very densely packed with a lot of really interesting work across a variety of different things. So we always start with, how did you initially develop your research interests? Maybe even going into your PhD and during your PhD, and then over time, how has that developed?
So maybe I should start before my PhD, actually. Long time ago, still this millennium, but early 2000s, I was interested in AI, but AI was very different. In particular, people didn't really use the word back then because it was during one of these AI winters where if you said you did AI, people gave you weird looks. So it was interesting in machine learning, I'd say. And I remember the first research project that maybe is more relevant to this conversation was on NLP. And back then, the idea was that we wanted to build these models to do part of speech tagging or named entity recognition. Right now, that's considered boring stuff, but back then it was really exciting. And one of the key challenges was lack of data, label data, that is. So the idea that if we learn models on a huge amount of raw text, we could develop better features that could help with classification. So the first project I did was train what I would consider a language model. So in particular, it was a hidden Markov model with a certain type of structure and train it on as many words as I could get a handle on. And what was cool about it is that it did improve accuracy on downstream tasks. And also, if you look at the clusters inside the language model, it was actually really interesting. It would separate all the city names and the people names and so on. So it was kind of the first taste of, hey, this is really pretty emergent, let's say. And of course, that line of thinking has been the thing that has gotten us to where we are. That was 2005, and I went to grad school. And I had this sort of a split interest. I was very interested in machine learning theory, and I was also interested in on supervised learning, nowadays called more self-supervised learning. The idea you can take raw text and you can learn different types of structures, in particular syntactic tree structures, and how that would emerge. And it wrote a lot of papers and I had a lot of interesting ideas. I think it proved a little bit challenging to get a foothold on the actual problem, because it would be this sort of mind reading game where you would design a model, you would train on data, and you would just hope that magically these Penn tree bank tree structures would come out. And there's no reason why that would have to be the case. So I pivoted. I think there was a period towards the end of my PhD where I pivoted to semantic parsing, which still satisfied the idea of learning latent structures from data, which is something that I had been really excited about, but with a real application. So the setting was question answering. So you ask a question like, what's the tallest mountain in California? And you would give it an answer, and then it would have to figure out essentially a database query, the SQL query that the natural language mapped to that would produce the answer. And then you could learn this end to end and actually get a pretty interesting system out of it. So I was very, at that time, excited about actually building real applications. After I graduated, I spent a year at Google where I built semantic parsers that then got used to power the Google Now or Assistant, things like that. And then I started at Stanford. So a lot of my earlier work was on semantic parsing. How do you have deeper understanding of natural language beyond just parse speech tagging or superficial clues? And this idea of natural language sentence mapping compositionally to a logical form with execution semantics, that was the paradigm that I lived in for a very long time. Then I think one of the main bottlenecks was that while in principle this paradigm worked beautifully and you could answer really, really complicated questions that probably would even be difficult for models today, most of the knowledge on the internet is not in structured form. So that's where there was a sharp drop off where much of the knowledge was inaccessible to this class of methods. So then I started thinking about more just general question answering reading comprehension. We created the squad data set around this time, 2016, as a way to kind of trailblaze into that area. And then so I sort of started shifting to thinking about evaluation. And at that time, I think I was spending a lot of time thinking about robustness of machine learning, because there was a suspicion that deep learning methods were able to do really well on these benchmarks, but you actually use them in real life, they would just fall apart. Right? And this was true, with adversarial examples, both in vision, but also in language. It seemed like these really high performing systems that topped these leaderboards, superhuman, actually just fell apart when they didn't work out of domain. So I did that for a while. And then, foundation models happened. GPT-3 came out, and it sort of just blew my socks off in terms of the idea that you could train a language model, just next word prediction, and you could get a model that did way more than I could imagine. Just zero shot in context learning, and all these capabilities just emerged. It really suggests to me that there was a paradigm shift. And then I think at that point, I sort of said, well, you know what, I could go on and break the system in these systems in all sorts of different ways, but I think that's not where the action is. I think the action is really trying to understand these systems, harness them for applications, and understand the social impact. So actually, around that time, 2020, I started thinking a lot more about the societal impact of this technology, which is timely because that's when this technology was really having a societal impact kind of worth maybe talking about. So I founded the Center for Research on Foundation Models in 2021, and then did a lot more evaluation work. I mean, I guess I just work on probably too many different things, but I'm happy to talk about any of them. But that's a long answer to a short question.
That's awesome.
One thing I'm curious is, since you've been thinking about this stuff since 2005, there are some old ideas, like, are you still interested in syntactic tree structures, or still interested in
semantic parsing
or these like more structured ways of dealing with natural language? Or do you feel like actually this new paradigm changes that as well? Like, it doesn't actually make sense to think about language in this more structured way?
Yeah, I think there's some nuance here. By and large, I think a lot of the internal structures, which are purely internal, I think are not needed. So syntactic parsing, for example, I think I've sort of given up on them being that useful. Even when I was doing semantic parsing, I think that syntax was a interesting formalism that captured one aspect of language. But when you're solving end tasks, there are many other things besides syntax that matter. So fixating on syntactic structures didn't really make sense. I think in terms of semantic parsing, if you think about the 2024 rebranding, it's just natural language to code, right? Because that's what it's about. It's about generating executable code given natural language that you can then execute. And in fact, there's been some ideas of thinking about latent variables that are still basically the same things in disguise from back then. For example, you can think about chain of thought as a sort of a latent structure that leads up to the answer. So the general idea of having an input where there's a sort of latent thing that you maybe don't necessarily care about that helps you derive the answer, that is basically the abstraction of semantic parsing. So at that level, I think many of that framework is still relevant. Now the techniques are different most of the time, but sometimes, I mean, there's still an idea if you have a latent variable and you think about writing down the marginal likelihood, that is still a useful thing. And I do see that sometimes some of the old ideas are rediscovered because of that, but that's fine.
That's really interesting. Kind of like old ideas that get rediscovered, but in a new way, kind of from first principles in the new paradigm.
Yeah. So how have the things that you're interested in shifted towards now? So that was kind of the beginning of foundation models. Great. Focusing on that. Like, what are the things now that you're really excited about this year or kind of going forward?
Yeah. So maybe just to actually complete the transition. So I thought about robustness of machine learning. How do we make the models robust? And I was working on semantic parsing. How do you answer complex natural language questions? And foundation models actually basically is the answer to both of them, in the sense that if the way you deal with robustness is that you just train on enough data that you sort of cover, there's no more OOD, out of domain anymore, or you try to pretend that it doesn't happen by training on as much data as you can. And it's very effective. We had some papers showing that compared to many of the previous methods, which were algorithmic, just having a good foundation model was the first order bit. And in terms of semantic parsing, it completely changes the game of what type of methods and data sets you even look at. So I was pretty bought in. And I think, going forward, for so much of my career, thinking about how to make models better and more reliable. And of course, we're not there yet. But what has happened is a lot of that work has shifted, at least the center of gravity has shifted towards major foundation model developers like OpenAI or Google. And so while we can obviously publish papers and still create new ideas that are then useful, for example, this year we had new optimizers and new ways of doing data selection, I think in terms of big picture impact, I think I'm gravitating more towards research problems that really point at a different structure about the way that things could be. And one of the things that I think is special to academia is that we have the ability to not worry about currently, okay, how do we build the best system? How do we get it out there? Whereas, in some sense, that is a lot of part of what academia does, but I think that isn't really maybe should be the focus going forward. But thinking about how, society could be structured, to put it, in the most grand terms possible. So I'll give you some examples of what I mean by that to round it out. Maybe starting with the concrete work that we have done and then moving towards work that we haven't done, but I like to do. We had Helm, the evaluation of language models, where we took all the models that are out there that we could get a hold of. We curated a large set of evaluations, and then we just did it in a standard way. This, I think, has been really influential. And the one thing I didn't maybe fully appreciate is to the extent to which having a neutral third party that does the evaluations, even though Google or OpenAI or anyone could have done this, has a certain contribution of which is that the neutrality and the legitimacy of that is worth something. That is one thing. Another project that we worked on is called the Foundation Models Transparency Index. And this is evaluating not models, but organizations. And so we were thinking about responsible AI and transparency and lamenting the fact that well, there's not that much transparency in the current world. But rather than just complain about it, we decided to be more scientific and measure this. So we developed 100 different indicators spanning did people talk about their data, talk about their compute labor practices, do proper evaluations, and all the way to thinking about their usage policies and so on. So it's a very comprehensive list. And we evaluated 10 organizations based on the set. And this is, again, something that can only be done outside the major labs because it has the neutrality and the perspective that we have, I think, is just by construction, not really replaceable. So these are examples which I've been thinking about, which cannot be done at major labs and also doesn't require that many GPUs. And then there is, I think, longer term, what I'm really excited about is a vision of how foundation models can be built. So the current status quo is you have all these people in the world who write books, write essays, take pictures, create essentially content, which then gets scraped up into data sets that are used to train foundation models, then serve people and products. And this has many structural problems. One is that the content producers don't get actually any credit or paid. So that's why you see many lawsuits that are happening. Another problem is that there's a massive amount of centralization in determining these models' behavior, which is, again, lack of transparency. So we don't know what's happening behind the scenes. And I just wonder how could we do things differently? So I don't have the technical answer, but just a kind of a vision to paint out. So what if we were able to actually attribute the predictions to the actual training source? So this is actually something I worked on 7 years ago, but in a more limited fashion. You could do data attribution and you could do it reliably. Then maybe you could actually set up a more economically viable system where you pay people for their contributions and that maybe incentivizes better data quality. And there wouldn't be the same lawsuits, at least, because maybe as long as people are getting paid, I think they hopefully will be happier. That's one kind of direction. The other direction is thinking about the values that these language models embody, which is something I think is really important to foreground and not just sweep it under the umbrella of we're aligning to human values and we're being safe and therefore, because that is such a complex construct that, especially for a single organization to say like, oh, don't worry, we're handling it, is just not a viable way forward. So how do you make this process more democratic? How can you elicit some values, or how do you have a governance structure that is more participatory and gets you more better, representation, so that the values of a language model are actually reflecting what people want rather than whatever a few set of people behind closed doors decided. So those are the directions I want to push. There's many technical as well as incentive policy questions on how to make this all work, but those are some things I'm excited about.
One of the things you mentioned that I really want to dig into is Helm, actually, in terms of the evaluation of language models and what that can look like going forward. I think that your point about it being work that is probably best done outside of the labs and outside of the major companies is probably the right place for it to be done. But I'm kind of curious to get your thoughts on how do we actually evaluate language models robustly, especially and for lots of different tasks. And it feels like it's going to be this huge effort of trying to understand, almost like standardized testing or something, but for a much, much wider class of capabilities than we've ever really had to do before. And it feels like it's going to be some huge effort. Like, how do you see that kind of going forward? How are you thinking about it?
Yeah. I think the standardized testing analogy is interesting because we've been trying to evaluate humans for millennia and we haven't really figured that one out.
Yeah.
We're getting general purpose enough models where that type of thinking may be actually relevant. Of course, the language models have other structures that maybe make it slightly easier. Like you can actually subject them to watch a week-long exam as opposed to having it done in 2 hours or something. I would try to break it up as follows. So we need progress along different axes. One axis is the realism of the evaluation. So language models are used or starting to be used in many different places in enterprises and consumer apps, and the societal impact and both in terms of accuracy, the benefits, and also the risks really should be contextualized to where they're deployed. On the other hand, evaluation typically centers around these very stylized academic benchmarks, which is quite far removed from the actual use cases. So one direction is actually to invest in much more realistic use cases. For example, if they're using a contact center or they're used to do information extraction from PDFs or something, how can you really capture that in the benchmark? So that's one axis. The other axis is the idea of open-ended generation is just hard, right? If you have a prompt, generate me an essay about World War II, and you get an essay, grading that essay is something that your English teacher would spend quite a bit of time trying to read and give comments and all that. That is a much different thing than like answering multiple choice questions. And we just don't know how to do that. There's also the problem is, people say, oh, just do human evaluation. That is really not an answer in the sense that, first of all, which humans, if the question involves deep knowledge about, let's say, the medical data, you can't just grab a random crowd worker and have them do it. So it requires experts. But then even if you have the experts, how do you scale? Do you do pairwise comparison? Do you do some sort of Likert rating? Do you have feedback? All these questions about how to even pin down what the evaluation should look like is pretty open. And then I guess there's another aspect of evaluation, which is thinking about safety. So I've been involved with working with ML Commons on developing safety evaluations. And it's just an open-ended question. How do you measure bias? Again, I think my tendency has been to always situate in the actual use case because then you can more meaningfully talk about any sort of benefits or risks. But it's just hard to define when there's not really a clear, correct answer. The silver lining is that evaluation has now, I think, in light of these foundation models, become more of a first-class citizen in a way that it was just not. Before, it was always you train a model, you evaluate. You never evaluate without training because if you come up with an evaluation set, there's no model to evaluate. But now we have these general purpose models that you can actually just focus on evaluation. And then I think that is really powerful because you can imagine going out and getting experts in some domain to sit down with you and gather a few hundred examples. Definitely not enough to do any sort of training, but enough, I think, to do meaningful evaluation. So I think the level of fidelity that we can get from evaluation should be much higher than before, just because the data demands are much less. And then there's a whole, how do you evaluate multimodal models, image generation? We had a paper on doing image generation evaluation, which is obviously a good step, I think. So there's a lot of work to be done, not to mention like multilingual evaluation and thinking about agents and how to evaluate just not the language model, but language models with tool use. We also have some work on setting up ML agent bench, which is a new evaluation for evaluating whether a agent can go on and do some machine learning task. It's a pretty vibrant space, so hopefully we'll make some progress as a field.
Yeah, this is really interesting. I talked to maybe 40 founders last quarter who are working on agents. And number one problem they all encounter is evaluation is too hard. And I don't know how to know if I'm making my agent system better or not. And a lot of people have solved it in really hacky ways, like creating their own like few expert examples. But this question of open-ended generation is really hard. I think we've gotten around it by mostly using question answering as like the basis for a lot of our agents. But I'm curious if you've seen any like nice ways of dealing with this open-ended generation problem.
Yeah, we've been exploring model graded evaluation, which is becoming more popular. First disclaimer, these need to really be taken with a grain of salt.
Yeah.
But I think just as saying human evaluation such and such is inadequate, saying model evaluation such and such is also inadequate because it really depends on how you set up the prompts and how you ask the questions. So in particular, I think to your point, if you can distill things down into question answering and you can be more precise about what you're looking for, then model-based evaluation, I think, can actually become viable and at least hopefully correlate with what you care about. I also think that, evaluation often has two purposes, right? One is an absolute benchmark of here's how the field is doing, state of the union kind of thing. And the other is that We just need some sort of metrics to hill climb on so we know that we're getting better models. These are actually very distinct. So even, for example, perplexity is obviously a very bad absolute metric of telling anyone anything about what the model can do because it's not really interpretable and not connectable, relatable to actually downstream outcomes. But it's actually, I think, a fairly good surrogate, at least for, let's say, pre-trained models. And I do believe in the power of surrogates. So even if you don't have the right evaluation metric, if you could develop a surrogate that is well correlated enough and you are not fooling yourselves and not gaming it, then I think it could be very productive. And so many of the evaluations are, for example, even like Blue Score is actually useful for certain types of regimes, right? If you think about like a fixed score and if you're changing the model but just varying one type of axis, let's say training model size, I think it's probably okay. But if you try to compare, it's not a good absolute metric. And certainly if you try to game it, then it's the metric loses meaning.
How do you think that applies as we start to have many different language models from Google and Anthropic and OpenAI and others? Like, how are people going to be able to decide like which model should I use? How good are these models compared to each other? Like, is this something that should be done more publicly and more broadly in some kind of benchmark, or does that end up just getting gamed? Is everyone just going to run these huge evaluations themselves for their particular application? Like, what do you think that looks like in the future?
Yeah, I absolutely think that needs to be a third-party evaluation done in a controlled way. I think just to complain a little bit, I think that everyone reports MMLU scores, but the way that they're, and you could, I'm not complaining about MMU, I'm complaining about the way that you get some numbers and the prompts that are used for MMU are all different. And sometimes you use like fancy tricks like self-consistency or a chain of thought or whatever, and you just get a number and it's not clear what you're exactly measuring. You're not really measuring the model, you're measuring the model plus any sort of prompt engineering and hacks that go on top of that, which is not quite maybe meaningful. And my philosophy is that we should absolutely measure everything in a standard way, and we should make things transparent. Because especially if you look at generative evaluations, all the metrics I think are going to be really approximate. And I want the ability for people to go in after the fact and say like, this automatic model graded evaluation is not good. I have a better one. And having the outputs actually of the models, actually having the outputs where you can inspect them, you can do further analysis, I think is critical here. And this is what Helm does. We make all the model outputs public so that people can go and have fun with it. But now, if everything is public, now you worry, okay, well, now people can just train on it either accidentally or purposefully, and then the model evaluations lose meaning. So that is true. But I think the way around that is you just have to have a constant flurry of new evaluations, which I think we need anyway, because as the capabilities of these models scale up, we want to measure different things. So we need fresh evaluations anyway. So let's create them and have the old ones just be sort of for legacy reasons. You have it, you know what it does, but don't trust it too much as an objective evaluation.
I like that actually as a kind of basically continually improving evaluation benches as capabilities improve.
Yeah.
I guess a question then is like, who funds this? It's actually kind of expensive to make high quality evaluation data where you're really thinking about the task and you're updating it over time and you're being really rigorous about these.
Yeah.
And also, like, as an academic, do you feel like you can get funding for something like this, or there need to be some AI safety institute that is like, or like some AI institute that's like government set up that needs funding, or how do you think about that?
Yeah, I mean, I think there needs to be a lot more funding in this area. If you look at the amount of funding going into model builds versus evaluation, it's completely lopsided. The amount of funding going to model build is many orders of magnitude, I would say, larger than into evaluation. And I think that, traditionally, 10 years ago, I think data sets weren't really appreciated very much. People really wanted to do the modeling work and the algorithms work. But I think that culture is changing. So NeurIPS has this new data sets and benchmark track, which actually I think is becoming to thrive. And I send a lot of things there. And I think it's a good venue to recognize the importance of benchmarks. And I think we need more, and not just academic funding to do creation of data sets, but also thinking more holistically about how we're charting out the space. Because I think a lot of evaluation work, for example, some of the work we're doing at home isn't necessarily aligned with like publishing the next paper, but we're just doing because we think that the world would benefit from it.
Mhm.
So AI safety institutes, definitely. So now the UK has one, the US has one, the EU is going to have one.
Mhm.
And I think it still remains to be seen what actually comes out of this. But there is movement, there is interest. And if we can channel that into actually funding the activities that can drive benchmarking forward, then I think this would be great.
That makes sense. Kind of shifting away from evaluations on the capability side or the model understanding robustness side, what are you most interested in? I know Alpaca came out of your lab, also like the I always forget the
Generative agents.
generative agents. Yeah. Simulacra paper came out of your lab. And these are very interesting explorations into capabilities and new techniques. And I'm kind of curious, like, how are you thinking about exploration there, techniques you're interested in? What feels promising? What does not? What feels underhyped versus overhyped?
Let me just clarify that before there gets to be too much confusion. There are agents gets talked about a lot, right? So this is definitely, I don't know if it's overhyped, but there's a lot of plenty of hype around it. There's actually two types of agents. So we publish on both. So the classical type of agents like ML agent bench is you basically have a language model that's wrapped around in some sort of architecture with tool use, and it is able to do more things than just a raw LLM. And this is what people typically think about, I think, agents. There's the other type of agents, which is exemplified by generative agents. And there, the idea is simulation. So there's no goal. People ask me, what's the goal? There's no goal. The goal is just to, I mean, it's really nice. I feel like so often we're like in ML, we're so goal driven, like what are we optimizing? There, the goal is just to simulate and see what happens. So you have a city of 25 agents, each backed by LLM, prompted to basically live their daily lives, they interact. And what you see is different types of emergent behaviors, social emergent behaviors, not in the within a model. And I think that's just really fascinating. One thing I think would be really interesting is what happens if you scale this up, which will require compute and fast inference. But if you could scale it up, maybe you actually have some interesting social dynamics and think about like governments forming. I don't know how it happened, but this is what happens when you put a lot of people together. They have to figure out something, and maybe LLMs can do that. That would be pretty awesome scientifically to wonder about. There's the other side of things, which is if you can get these models to actually faithfully simulate humans, then you can imagine doing all sorts of, social science and economic studies on human behavior. Many studies that you want to do are in social sciences are difficult because you have to recruit the subjects. And even if you recruit the subjects, you can't give the same person both the control and the treatment, and also some things are unethical. But with LLMs, are liberated from all that, and you can do a lot more interesting studies. Now, the caveat is that these are not real humans, so it's not exactly, you can't just immediately take the conclusions, but it gives you just another vector to be creative about getting insights into. So that's, I think, something that's underexplored, I think, but pretty interesting and promising.
That's super interesting. Actually, the first time I've heard of this, like many agents interacting as a way to do simulation of human systems and like as a way to do science. Like we can come up, maybe discover new mechanisms for governance or things like that. Yeah, through this. That's really interesting.
Yeah, exactly. For example, people are debating about, okay, what COVID policies should we have?
Right.
And you could say, let's simulate it. You simulate this COVID policy, and then people walk around and everyone gets COVID, and it's like, okay, bad idea.
Josh is dying here.
This line of thinking makes me so uncomfortable. I can see some scientific value, for example, if we end up discovering some new type of government system, we can think like, oh, does it actually make sense? Sure.
Right.
But my worry is certainly that people will take these as evidence and say like, oh, well, this is the good COVID policy, and sort of not dig into the scientific nuance that kind of is required for these tools.
But like with all the real problems, this is also a sim to real problem. So it's like, okay, how much can you trust the simulation? We obviously have to be careful about that.
Although it's really nice in other sim to real settings like robotics, you make the robot, it falls over. Guess my simulator isn't very good. Here, you make your civilization, it falls over. Like there's bigger stakes to that. So
Yeah. I think there's a while before we actually like rewrite the Constitution using it. So don't worry too much about it. But yeah, it's a point taken that we need to like have a heap of salt ready when we listen to the results.
But the idea is so interesting. I love it.
yeah.
What about other things on the kind of exploring the capability side? Are there areas that you are interested in, or areas where you feel like, these are major blockers? We talked a little bit about data attribution in terms of values, and we'll come back to that. But are there other things that you're interested in?
Well, look, since we're on the topic of agents, just touching on ML Agent Bank. So like I said before, ML Agent Bank, it's set up as a benchmark for agents that are meant to solve, let's say, a category competition. So you give a category competition, agent make accuracy go up by 10% over a baseline. So right now we have a range of tasks ranging from fairly easy, probably because it's in the training set of these language models, to things which it's getting like everyone's getting 0% on. So I think this will be interesting to track. And the thing that I find exciting about this is that being an ML researcher, this selfishly directly helps me in the sense that it's not some random QA tasks that don't really have a personal interest. If you can actually solve this can improve research itself. And so that's feedback loop could be interesting. Yeah. So I'll just leave it at that.
Yeah, agreed. The kind of wild way of thinking about this is ML agent bent is like the first step to recursive self-improvement, where the recursion involves a bunch of humans trying to improve it.
Yeah, that was what I was thinking, but I didn't want to say it.
Don't worry, I'll say it for you.
Although I think like with many safety things, when you look at the real world version of this, it's not so scary and it feels quite a bit more reasonable. Like if you want to have a recursively self-improving LLM, cool. So now every 6 months when you're training your new 6-month training run, you get a little bit better at it. Like there's actually really long time frames for a lot of these trainings. They're involved in things. Like it's not like a science fiction story.
Yeah, I think the scariness really depends on the way that you think about how dangerous LLMs are. Let's just put it that way. Which is actually some other topic maybe we should touch on at some point.
I was just going to ask you about that. Yeah, how do you think about that?
How do you think about that? Yeah.
So first, I should say that we should all be very open-minded and entertain all possibilities with non-zero probability, like a good vision. Because frankly, I've been very surprised by how these models, and I think everyone has been surprised by how far you can get with these simple principles. So I've sort of learned my lesson in some ways to not think, oh yeah, that's never going to work because it can't do X, Y, Z, because anything I can go. That said, I think there is a real lack of rigor in the discourse about the risk. And I understand that, yes, future risk, there's a lot of unknowns, but just of saying the word unknown doesn't get you off the hook for trying to at least try to be rigorous. And I think that one thing, a particular thing I've been thinking about is open models, because I think as a scientist and as a researcher, that's all we do. We do things openly. We want society to benefit. And so that's sort of the core value proposition. But at the same time, people talk about, oh, well, if you put all these open models out, if GPT-4 or GPT-5 were open, then we'd be all doomed. And so that raises the question, okay, so let's talk about it. So how much of a risk is it? And to think that from that point, you need to think about what are the threat models, right? Okay, so you could break it down. There's, for example, disinformation. There's cyber attacks. There's bile. There's CSAM. Those are, I guess, maybe some of the favorite ones that people like to think about. And then there's more exotic varieties like loss of control and AI takeover and things like that. But for each of these, I think the type of way you would think about the risk, the type of regulation, needs more consideration. And one thing I think is lacking in this space is just measurement of how much of the risks of these are, and particularly thinking about marginal risk of a model versus not having it at all. So for example, there's these studies that show, well, okay, you can prompt Llama 2 and it can give you instructions on how to synthesize bioweapons. Okay. And if you look at that, it's like, okay, no, shut it all down. I mean, that's, I think, obviously the wrong response, because if you go out on Google, you can actually find all these things. And also, even if you could find a recipe for it, you still have to manufacture it. And all my biology friends tell me that that's actually the hard part. It's not that easy. just think about it. I think for AI researchers, you could say, okay, how do I build an LLM? You ask ChatGPT, you can do this, and it'll still give you the steps. And it's like, oh wow, now I know how to train it in a language model. But actually, there's obviously a lot more complexity, and the execution really matters.
Yeah.
So I think we need to think carefully about assessing the actual risks rather than just being somewhat superficial about it. And so again, it goes back to evaluation and how we measure these things.
There's actually a really interesting point here where you talk about open models, and there's probably like a pretty reasonable argument that the fear mongering shut it down. It actually tends to centralize power and like moves toward a more control regime around the capabilities as opposed to like a more open regime. So if we're not actually realistic about assessing risks, like there's actually a big harm, which I think people don't talk about, the big harm to fear mongering, which is that it centralizes rather than distributes power.
That's a piece of it, yeah.
Yeah, definitely. I think there's a lot of fear. The fear to like evidence ratio is extremely high, which can lead to all sorts of, I think, fairly bad regulatory proposals. Like if you say, let's say, liability, model developers liable for everything that happens downstream, then you essentially kill open source, or at least like strong open source models. Or if you have a lot of requirements for models which might be even well-intentioned, you could shut out the small players, because if you have to do a $20 million exercise in evaluation every time you release a model, then just who's going to be able to afford this? So I think there's a lot of consequences that need to be taken into account. And it's not to say that depending on the risk, I mean, maybe we have to incur some of the cost. And I'm definitely not in the camp where just to let it all loose, everything will be fine. I do think we need responsible practices, but I just think that a lot of them can happen in the open source, and we need to invest again more into safety and understanding. And I've argued that actually having things done in open is better for safety, because at least if you look at the analogy with computer security, security through obscurity doesn't work. But if you have things out in the open for everyone to inspect and scrutinize, then you can actually get more secure systems. Now, AI is a little bit different. I don't think the argument completely just translates automatically, but I think that some inspiration we can look at that has worked in computer security.
One question I had around open source is, so we're in a regime that kind of violates the previous principles that open source was built on. For example, like in software open source, anyone can really contribute to the capabilities of the software system, whereas in this model regime, it's not really the case. The model has to be developed and trained by some set of people, and it's actually really hard to make like an open source project in the traditional software sense. And I'm curious if you have thoughts on like evaluation benchmarks. I can see how that traditional regime can apply, but for model training, do you have thoughts on going into the future, how that could apply?
Yeah, okay. I'm glad you brought this up. So notice I didn't use the word open source, just open models. And because this is not open source software, it's a completely different artifact. And the closest analogy I can think is that these are open binaries. So the weights of a model being out there is not the same as a source code being out there. You can execute the model, but you have no idea if you can't really directly modify it except for maybe through fine tuning. You don't know if there's any backdoors. You don't have no idea what the training data or anything about the model is, which is very in stark contrast to you have the source code of Linux. In theory, you can go read the millions of lines of code if you wanted to. At least it's auditable. So that's a sense in which it's already very different. On top of that, even if, let's say, the training data were out there, it's clearly different because, like you said, the method of contribution is very different. In source code, you find a bug, you can submit a PR, you can patch it up, and people can kind of contribute back to this thing that is constantly, hopefully, getting better over time. Whereas a model, some big organization trains it, releases out there, and it's sort of frozen. There's no recourse. There's no bug fixes. If someone doesn't like something, you can't really change it. You can fine tune, which is a very different mode. And fine tuning has actually some advantages because you don't have to have very much expertise to really customize your model. So that's a big plus for customizability. But the lack of backward contributions makes it very different from open source. But I think the closest thing to open source would be like you have the training code, the data, and the model weights available for everyone to see.
And then you still just need the compute to like actually run the training run.
Yeah, so the compute part is definitely a problem. But at least if you add the training data and the model code and maybe some intermediate checkpoints, you can actually do an oddity analysis on the model, even if you weren't training it from scratch.
That makes
Mhm.
sense. On your point about fine tuning, one thing I'm curious about is whether you have intuitions, and this kind of goes back a little bit to like what representations is the model learning and when and from what data. Do you have intuitions on what pre-training is doing versus what fine tuning is doing? Something we've been running internally is like using different types of data in pre-training versus in fine tuning and seeing how does that actually impact the end results. And kind of like some interesting early findings, but not super clear. I'm curious if you have any thoughts.
Fine tuning and pre-training, I think, at least logically, occupy very different functions. If you think about it from less of a perspective of an individual organization building a model, but what happens sort of at a kind of ecosystem level, where the model provider builds like a raw model that's really good and has knowledge and reasoning and all that stuff. And then I imagine ideally there would just be a plethora of different fine tunes that happen, which are customized to a particular organization's or user's needs.
Mhm.
And so that's one way that you can think about fine tuning. If it's within a single organization, then I think really doesn't matter. I mean, it's just like getting the job done. And if you want need to mix it, you mix it. But I think maybe what's more interesting about foundation models is that there is this interface or handoff that can happen. Like you could do part of the work and you can hand it to someone else and you can hand it to multiple people. And that's sort of the powerful part of it. And there's, I think, a really also interesting work around like model merging that happens. So once you fork, then what happens if you bring everything back together? So Colin Raffel has actually some really interesting thoughts about how to think about model builds as similar to how you would do version control for software. The analogy isn't quite there yet. There are obviously differences, but I think it's inspirational to think how we can make the model building infrastructure more mature.
On that note, how do you think about, and I think we touched on this a little bit earlier, but how do you think about academia improving capabilities, building models, et cetera, relative to the sort of commercial larger companies building these things, open sourcing them? Like, is it even worthwhile for people in academia to be trying to push the frontier of capabilities? Or are we entering a regime where it's like, no, we can only kind of like build on top of these like artifacts that are provided and sort of study them, but we aren't able to really like push capabilities forward in the same way as in the past?
Maybe a less binary framing that I'm curious about is like, where does academia play when it comes to capabilities? Like, what is this?
Or is it worth having academia? I think some people are proposing like, oh, like we should have a big compute cluster, like we should be able to train our own foundation models. Like, is that a worthwhile effort or is that duplicate and kind of a waste?
Yes to all of the above. So let me I try to break it down. So without the big compute cluster, I think that academia has multiple functions. One is, as usual, it's constantly should be creating really novel ways of doing things, proving them out, and someone can scale it up, right? So I think there is a difference between doing things at small scale with intention of doing things at small scale and doing things at small scale with intention of scaling up. For example, we had some work on optimizers. We have this new optimizer with Chen Ma and his students, which can actually outperform Atom by like a factor of 2. And this is something that we can just do in academia. We haven't proven it, so we still need to do that exercise. But I think if you think about academia as generating ideas, I mean, this is certainly promising, and someone should try it at scale. There's also, for example, flash attention. I think was one of my favorite examples of something that came out of academia and now is like everywhere in industry. So I think there's always, I think, still space for producing these more fundamental changes to how model building works, or actually another one, direct preference optimization, DPO. That's another, and I think that's a really influential piece of work that you don't need that much compute to honestly to do that. So there's a lot of things you can do on the method side. Then there's evaluation. We already talked about that and how being a sort of neutral third party and thinking deeply about the evaluation is something that I think we're just as good as, if not better than people with a larger compute budget to do. And then there's the long-term stuff about how do you do data attribution and how do you retool the whole incentive system. I don't think industry is just going to touch that because that's really thinking at a societal level rather than an individual organization trying to build a model. And so that's where I think academia can shine as well. All that said, I mean, even without compute, I think we can be kept busy and there's a lot of valuable, productive things. However, I do think that is necessary for academia to have way more compute than it has now. Because I think the goal is not to train a frontier model. There's no delusion that we would have the same amount of compute or even anywhere close, OpenAI or Google or even some of the startups. But I think you need enough to be in a regime where the idea has been proven out. And that's the key thing. And that line, I think, will only increase over time. And so at least being at that level will allow you to continue to ideate and think of things and be relevant. For example, if you didn't have any, let's say you have 0 GPUs, like no matter, even if you're thinking about the large scale, you just can't do anything terribly useful because you need, let's say, I don't know, to try out a new architecture, you should probably go up to a few low billions of parameters just to be able to prove out the idea and hope that, of course, there's still another challenge to scale it up to, let's say, 70 billion or something. But at least you need to go to that and you can't train like a 1 million parameter model and expect it to generalize. So I guess just a summary, I think that the goal of academia should always be to think about what are the key conceptually new ideas that can push things forward and be relevant at scale. And the amount of compute should be proportional. It's hard to give you a number exactly, but it needs to be enough so that you can actually compute the scaling laws and far out enough so that you can credibly extrapolate the rest.
That makes sense. That's really interesting. Earlier, you had mentioned, thinking about the values that these language models embody, how it's really important to think very carefully about this question of like aligning to human values. A lot of people talk about aligning to human values, but obviously humans have lots of different values. It's very complex. And you pose this question of like, how would you make this process more democratic? Figuring out what values a model exhibits more democratic or more participatory. Do you have any thoughts on that?
Yeah. Some of this is at more the governance level. How do you even figure out what people's values to pay attention to, how to aggregate them? There's been some preliminary work. I think the Collective Intelligence Project, CAP, collaborated with Anthropic on creating this collective constitutional AI, which is interesting. They collected a constitution which consists of 1,000 statements from a broad range of people and prompted basically Anthropic's models to pay attention to that constitution. So that's an interesting early idea of that. I would hope to go a little bit farther in the sense that at the level of abstract principles, I don't think there's too much disagreement. Okay, these language models should be helpful and harmless and fine. Okay, that sounds good. So it's really about the specifics of, is this piece of text, should that be considered toxic or should I allow this? And all the nuances where I think you really want to get people to really not just vote, but also deliberate and debate over what is the best path forward. And there are some things that you can sweep under the umbrella of personalization. Like if you prefer short responses, I prefer long responses. We don't need to sort out that value. But there's also some things about whether climate change is real that we don't want personalization. We want some sort of objective truth there where there needs to be some deliberation. So one way to think about it is you have a bunch of people with different values and you're trying to aggregate. I think that's just maybe the first piece. But then the other piece is that, can you really think about language models as a deliberation medium that allows people to sort of contribute their preferences and belief in, but also going the other way, get educated about some of these views and share and debate with other people so that there's sort of a consensus that forms among the community about some of these issues. I think that would be, the ultimate dream is that these language models can be sort of mediator in some sense.
That's really interesting.
Pushing back on that slightly, like, do we want something that is mediated in a single model, or do we want more of a diversity and plurality? There's certainly going to be places where two groups of people definitely don't agree about a particular thing. And you want to have maybe the dream is not, some models that are mediating, but maybe the dream is like many, many different models. And I think one of the reasons for pushing for open source is that it does kind of push in this direction. The more open source models we have and the more competitive they are, the more we have like a ecosystem and a plurality and diversity of views and capabilities, et cetera.
Yeah, that's definitely right. And that's one of the benefits of open models. I think that one way to, of course, the goal is not to get everyone to agree, but I think there's I guess the saying is like agree to disagree kind of thing, because I do think that we live in a shared world. And if everyone has their own customized model, which really is a little virtual world that they live in, that's basically how you get polarization. And I think that is a problem that you would want to fight. If you think about each of these language models in the future, I think a primary way that we'll interact with the world and get information and also take actions in the world is probably going to be mediated by these models. So that better be tethered to reality and not just based on some money-making ad scheme that gets people to basically believe whatever they want. And there needs to be some sort of shared reality, if nothing else, because the real world sort of demands it. Like there's some election that's going to happen, and you can't live in a world where half the people think this person's president and the other half the people think this other person's president. But yeah, to your point, I feel like figuring out that delicate dance between plurality and consensus, I think that's one of the kind of the key questions here.
That's really interesting. Yeah, it's kind of a core duality. You want both, actually, but it's tricky to figure out.
Yeah, I think you want to partition somehow the issues in some way. People can have their own favorite music and not pay attention to the music from another genre if they don't feel like it, but everyone has to confront the political realities of the world and the environmental realities of the world.
I don't know if that's 100% true. Like we've got, relativity, breaks up like old sort of science. Like there's a lot of like, where exactly does that line fall, right? Like there might be things that sort of scientifically feel very like settled, and then someone kind of pushes back against this orthodox view that of course the earth or the sun revolves around the earth. Like why would we think differently, right?
Right. You get like paradigm shifts.
Yeah.
So you want to allow for paradigm shifts, but that's paradigm shifts. That kind of paradigm shift is about better understanding reality. So like we ended up with this paradigm shift of the earth revolves around the sun because it's true. We think, at least as far as we can tell. Maybe there will be another paradigm shift. So this is about getting closer and closer to reality, enabling people to get closer and closer to reality, which I think is also true of what Percy you're saying. Like about.
Josh, I think you bring up a good point that you need to allow for this crazy person to go say something that everyone else disagrees with. You don't want 100% lockdown, and there should be space for that. And that's maybe one of the things like that should be built into this process. Like the temperature shouldn't be zero for the language model. So that's a good point. But I think that could be built into the system. We just have to be deliberate about it.
Yeah. Aside from what we have already talked about, do you have any strong intuitions or theories or big open questions that we haven't covered about important directions?
And perhaps in particular, thinking about it as like, for people who are listening, thinking about whether they come join your lab, like what sorts of things
come
are you
study,
looking for?
In order to understand X, kind of like a call for students.
I think that we live in such an exciting time, and I feel like it's like the 90s where the internet revolution was happening. Like there was a lot of uncertainty how the internet should evolve, what kind of impact it will have, and many questions about how the foundations of a brand new nascent technology is laid are extremely important. And I would just maybe, encourage everyone to think about things from a more systemic perspective, because I think a lot of ML researchers still tend to think like, okay, we have these models, they're really cool, how do we make them better? But I think there's the way that things are laid out and who has the power and to influence things, I think are critical questions that I think often get neglected if you have a pure CS mindset.
Mhm.
But at the same time, these are, I think, questions that need technical input. One thing that we didn't talk about, which I'll just throw out there, is we've been also thinking about watermarking for language models. And as some people know that these watermarks are talked about a lot in policy circles as a tool to, it's the only thing that people can agree on for trying to track bot generated text and guard against disinformation and things like that.
Mhm.
But this is like such a open technical direction, how to watermark reliably. We've been doing some of the work for language models.
Mhm.
And that research feeds directly into the policy discussion because there's a difference between being able to do it reliably and not being able to do it. So I think a lot of the technical work does have an impact on how things are set up. And again, going back to the 90s, thinking about the internet and how we have these levels of abstraction, we have net neutrality, we have this open standards. I think just imagine a very different world where there's one organization that owns the internet and every single packet is inspected for malicious use. I mean, that's just a very different world that we don't want to live in.
Mhm.
And think about the analog with AI today. I mean, I think there are many decisions which were made back then that we're sort of stuck with for
Mhm.
better, for worse. For example, security for the internet was sort of afterthought, and I think we've suffered a bit. Identity is something that we don't really have a good sense of, and that has caused a lot of problems. So I
Mhm.
think what's exciting is to think about architecting the technology stack at a societal level for foundation models and AI going forward.
I love that. That's a great note to end on, which is that this is where we are in the world. We're kind of at the beginning and everything is getting built now. And so come join us.
Yeah.
Thank you, Percy.
Yeah, thank you very much. This was great. This was
yes.
a great conversation, and we
Thank you.
really appreciate it.
This was a fun conversation.
Thanks for listening. If you like this, please consider giving us a rating and leaving a review on Apple Podcast. On Twitter, I'm @Kanjun, Kanjun. Until next time.